nuclear fission, fusion, and working of nuclear power plant. Nuclear fission. Nuclear fission is a nuclear radioactive decay process in which heating of neutrons on a uranium atom, then the uranium atom splits into two and it releases three neutrons. Each process releases two uranium atoms and three neutrons, a chain reaction of atom splitting, and ensure that there is a constant source of heat, meaning that it generates lots of heat. This heat is used to convert electricity. Nuclear fusion. Nuclear fusion is a reaction in which two or more atomic nuclei, usually deuterium and tritium, combine to form one or more different atomic nuclei and subatomic particles. Nuclear power plant. A nuclear power plant is a thermal power station which generates electrical energy from heat. At a basical, a factory making lots of electricity enough to power a city of 2 million people. Nuclear energy is the world's second largest low carbon source of electricity. Approximately 10% of global electricity is being generated by nuclear reactors. As of April 2020, there are 440 operable power reactors in the world with a combined electrical capacity of 390 gigawatts. The USA is the world's largest producer of nuclear power, accounting for about 30% of worldwide generation of nuclear electricity. The country's nuclear reactor produce 772 terawatts in hour in 2022, which means 18% of total electrical output. The nuclear power plant consists of numerous buildings and facilities, the most important which are follow the containment building where the nuclear reactors are fixed. The nuclear reactor consists of three core components: fuel elements, moderator, and control rods. Fuel elements. Fuel elements consist of cylindrical rods put into bundles. A uranium oxide ceramic is formed into pellets and inserted into cycloid tubes that are bundled together and containing fissionable nuclei of uranium 235 or uranium 238. The number of rods varies greatly according to the size of the reactor. The fuel elements are placed inside the reactor core. Are immersed in water which acts as moderators. Moderators is essential in slowdowning the energy of neutron in nuclear reactor, which are produced during the fission process by the fuel elements. Normal or heavy water is used in the moderator. Thermal neutron produce efficient reaction with uranium 235, and during this process new neutrons are given out which have an energy above 1 meganeutron volt. These new neutrons typically from other fission process as they accompany by a huge energy with them. Place with a slow down neutron by striking them with the fuel elements, a liquid or gas circulating through the core, and the moderator functions also as a coolant. Usually, steel vessel containing the reactor core and moderator or coolant, but it may be a series of tube holding the fuel and conveying the coolant through the moderator. Control rods. Each single fission reaction leaves spare neutron, which in turns are utilized for more subsequent reactions. The control over the speed neutron available at any given time, the rate of nuclear chain reaction are controlled. This control on the fission reaction can be maintained by using control rods. Control rods works by observing the excess or spare neutron in the moderator to prevent any further fission reaction. These are made up of boron, and cadmium. Apart from the above, three other important core components of the nuclear reactor are as follows: pressure vessel or pressure tube, pressurizer, and steam generator. Now we have understood the various elements of nuclear reactor. Let us see the entire operation in the nuclear reactor. The changes into stream. This stream turns the turbine, thereby starting the generator, which produce electricity and lightening up our world.